All right, 11.6. Two more sections to go, and that's it for new material. Okay. So we've been working with rational expressions. Okay. Last week you multiplied and divided with rational expressions, and then in 11.6 you're adding and subtracting with rational expressions. Okay. So remember that a rational expression is just like a fraction with a numerator and a denominator, and then the difference is those numerators and denominators have rational expressions in them, so they're not just numbers. Okay, so remember when you had a fraction that had like denominators, you just added or subtracted the numerators, right? So if you had like 4/13 plus 3/13, the same number on the bottom, so you would leave that and then just add the numerator, okay, and you would get 7/13, right? Same thing with subtraction. So it's going to work the same with rational expressions, okay? So if you have a over c plus or minus b over c, same thing in the denominator, then you keep the denominator, and then whatever the operation is, a plus b or a minus b, okay? And then simplify if possible, right? So same concept as fractions, okay? So if I have 3y over y plus 5 plus 4 over y plus 5. It is the same thing in the denominator, so I keep y plus 5 in the denominator, and then I just add your numerators. So I get 3y plus 4. You would have to try to factor, right, and simplify, but 3y plus 4 can't be factored. So that would be your answer, okay? So same thing in the bottom, just add or subtract the numerators. So we have n minus 3 over 2n minus 3 over 2n. Okay, same thing in the denominator, so it would be 2n. And then in the numerator, it would be n minus 3 minus 3. And then you would have to simplify n minus 3, and you would get n minus 6 over 2n. Try to factor the numerator and you can't. So you get n minus 6 over 2n. Okay? So when it's the same thing in the bottom, it doesn't change, right? Just add or subtract what's in the top. All right. One more. So we have 1 minus x over 2x squared minus 7x plus 5 plus 3x minus 3 over 2x squared minus 7x plus 5. Okay, so the same exact thing in the denominator. So we're going to leave that as 2x squared minus 7x plus 5. And then the numerator, so we take the first one, so 1 minus x, and we add the second, so plus 3x minus 3. Then you simplify, okay? So in the numerator, we get 1 minus 3, so negative 2. Negative x plus 3x would be plus 2x. And then can you factor the denominator? Right? So 2x squared minus 7x plus 5. We spent a whole chapter on that, and you can. So you would get 2x minus 5 times x minus 1 in the denominator. Then see if you can factor the numerator. And you can take out a 2. So we're going to get 2 times x minus 1 over 2x minus 5 times x minus 1. Then see if there are common factors to both numerator and denominator, and there are. So we can cancel out an x minus 1, and we end up with 2 divided by 2x minus 5. Remember, the 2's can't cancel because it's not a factor of the denominator. It's part of a term, but not part of a factor, or it's not a factor. Okay, so same thing on bottom, just perform the operation on your numerators. Then, when you want to add or subtract rational expressions that don't have the same denominator, okay, it's the same idea as when they were fractions, right? So if I had, let's say, one over 4 plus 3 over 22. Okay, we look and say they don't have the same number on the bottom. So what I need to do is I need to factor the denominators as much as possible. Okay, so 4 is going to factor to 2 times 2. Okay, then 22 would be 2 times 11. So I need to make the denominators the same. Okay, so then I'm going to look and say, okay, what does this one have that this one does not? So they both have a factor of 2, but this has another factor of 2. Okay, and then this has a factor of 11 that this one doesn't have, so multiply by 11. Then whatever I did to the denominator, I have to do to the numerator. So I needed to multiply by 11 here, because that's what got multiplied to this denominator. And I need to multiply by 2 here, because that's what got multiplied by that denominator. So I end up with 11 plus 6 over 44, because 2 times 2 times 11 is 44. Okay, and 11 plus 6 is 17. And then simplify if possible. Okay, but there's no common factors. So the first thing you had to do was find a least common denominator. Okay, and the same is going to be true for rational expressions. Take your denominators, factor them, and then try to make them look the same. Okay? All right, so I have 5 over 3x cubed plus 7 over 6x. Okay, then I need to factor. So 3x cubed is going to be 3 times x times x times x times x times x. Okay? Then I'm going to do the same thing for 6x. 6x is 2 times 3. So we're going to get 2 times 3 times x. Okay, then we're going to look to see, okay, what factors does this one have that this one doesn't? Already has a 3, already has an x. So this denominator, I need to add in or multiply in another x and another x. So what I multiplied in was an x squared. So I'm going to multiply the numerator here by x times x. Okay, then I'm going to look at this one and say, okay, what does this denominator have now that this one doesn't? Well, it was 2, so there's not 2 as a factor. So I need to put in a 2 here and a 2 in the numerator to keep it balanced. Okay, and then there's everything else. So then I can now simplify this. So 5 times 2 is 10, over 6x cubed plus 7x squared over 6x cubed. And then I try to factor this numerator, and I can't. So I get 10 plus 7x squared divided by 6x cubed. Okay? All right, one more for this. So I have 2x squared over x plus 1 minus x minus 1 over x. Okay. So I need to try to factor both denominators. Can you factor x plus 1? And you can't. It's already its own factor. So we get x plus 1. Then can I factor x? Well, it's already factored. So as a product, that's x. Okay? Then I look to see what factors does this one have that this does not. So the factor is x plus 1. So I'm going to multiply both top and bottom over here by x plus 1. Then I look and say, okay, what does this one have that this doesn't as a factor? So something that's being multiplied. Okay, and it doesn't have an x. So I'm going to multiply both top and bottom by x. Then I get 2x squared times x, which is 2x cubed, minus this product. So x minus 1 times x plus 1 would be x squared plus x minus x minus 1, all over x times x plus 1. Simplify another time, so I get 2x cubed. This simplifies to x squared minus 1. So I'm subtracting this whole thing, so it's minus x squared plus 1 over x times x plus 1. It's not necessary to multiply out this denominator, okay, because you're looking for factors. So you would try to factor 2x cubed minus x squared plus 1, which you can't, so that would be your answer. Okay, so when you're subtracting, make sure you distribute that negative to everything in the numerator of the second rational expression. Okay, so that is not multiplying. That is adding and subtracting rational expression.